Hey guys, today's video is about data mining. We'll go through its definition, methods, and application. Before we talk about data mining, we need to know KDD, which stands for Knowledge Discovery in Database. KDD is an overall process of extracting knowledge from the data, while data mining is just a step inside the KDD process. The first step of KDD is data cleaning, where we remove incorrect information and inconsistent data. For example, in a survey, we may intentionally design two questions on similar topics. If a person's answers in these two questions differ a lot, we may remove the data for consistency. The second step is data integration, where we combine data from multiple sources and form a single data set in single location, such as a data warehouse. The third step is data selection, which we choose the appropriate data for the purpose of analysis. The fourth step is data transformation. It can be any kind of conversion. You can change the format, the structure, or the values of data. For example, you can aggregate the data and make the time intervals longer, or you can simply convert the data from type integer to string. It all depends on how you want to apply your data in later analysis. The fifth step is data mining, which we will cover in detail later. The sixth step is pattern evaluation. It's essentially based on the result of data mining that we determine which results are important or useful. The last step is knowledge presentation. It's the final goal of the whole KDD process that could be applied in making business decisions, getting new insights, and solving existing problems. Alright, so what is data mining? Data mining is the process of discovering and extracting interesting patterns from large datasets. So what does pattern mean exactly? There are multiple ways to interpret pattern. First, data generalization can be operated on data warehouse. For instance, we can characterize or discriminate data through data cube and OLAP, which is online analytics processing. To be more specific, data cube looks like the picture on the right. Each dimension represents a variable. However, we only present three-dimensional cube for the limitation of visualization in two-dimensional surface. In the real world, you can store any type of data in as many dimensions as you want. Moreover, OLAP is a technique that we use queries to quickly extract data from the cube and make the analysis faster. Second, finding frequent pattern and association is a popular application of data mining in marketing. For example, we can try to find patterns in these four recipes from a fruit vendor. If we look closely, we can see apple and guava were bought together a lot. In fact, we can conclude that 75% of our customers who bought apple also bought guava. Well, we need to be careful that the sample size is too small in this case. Another important thing is association. Say we have sales numbers for A and B, and we draw the scatter plot like this. We can tell that customers who buy A more also tend to buy B more. Maybe the two products are food ingredients that are typically mixed when cooking. Although you may notice this point is far from the remaining points, we normally consider it as an outlier and just ignore it to avoid overfitting. Third, classification is useful in filtering junk mail and in a lot of aspects. The idea is that the original data contains blue and red points. We draw a line between these two categories and use this division to infer which category should the new point belong to. Say, this green point shows where the new data is located in. We classify it as a red group since it's on the left-hand side of the line. Next, clustering is similar to classification, except it is unsupervised learning method that we don't know the category of each point beforehand. The outlier detection can be a result of clustering, which we conclude the points that don't belong to any group as outliers. For example, we have this unlabeled data set, so we have to define a label by ourselves. An intuitive division would be something like this, which we group the closer points together. The point on the bottom left corner doesn't belong to any group, so we consider it as an outlier. The green points represent the new data, and we would typically classify it as red group since it's closer to the red group. In fact, there are a lot of distance calculation methods you can choose when classifying a new data point. So, in this case, the classification and clustering generate similar results. However, the point on the bottom left corner was not labeled when clustering, although it does belong to the red group. After knowing what a pattern is, we can discuss what makes a pattern interesting. This judgment call is mainly subjective, that we don't have a standard to follow, but we do want to achieve some general purposes. First, the pattern should be potentially applicable in the real world, such as in business decisions. Second, it should be easily understood and interpretable, although we sometimes sacrifice this requirement for the better prediction result. Third, it should be novel or validate a hypothesis. For example, we may suspect apple and guava are often sold together, and we can confirm our suspicion from generating the association rules. Also, anything that is of your interest can be considered as interesting, so it all links back to what you want to get in the beginning. After finding some interesting patterns, we have to decide which of them are significant and reliable. This will highly depend on which data mining method you are using. For example, we may measure the distance of each cluster to infer the reliability of the clustering. Both clustering shown are correct, but you have to choose the one that fits your purpose better. To be more specific, the clustering on the right-hand side is more compact, but it may overfit the data and generate too many clusters. On the other hand, the clustering on the left-hand side is looser, but it captures the general trend better. The last part is privacy protocols. This is important no matter which data mining method you are using. You must obtain a consent from participants when collecting, using, and disclosing their personal information. So that's pretty much it. Thank you for watching my video. I hope it helps you understand the basic idea of data mining.